My name is Pavel Vishnikov. I'm representing the company YQA. So my question is how you manage these projects, which is around the world. Who is in charge of the projects, and what are the final products you produce? Whether it's machines or what materials, what we can see at the end of this.
So that was two questions. Who's in charge and what are the products? Those sound like easy questions, but the answers are more interesting and complex than what sound like easy questions. So first, for the second one, one product is young kids, old people get excited about science and technology. It's just simply, in many parts of the world, there's despair over declining enrollment capacity for engineering. So one product is engagement in science is cool. One is education. We're training people in frontiers of advanced science and technology in a scalable, hands-on community way. So it's a faster, cheaper way to do technical education. So one product is education. One of the things we're doing is creating infrastructure. So one product is things like community computing infrastructure, facilities. One product is products. The labs are creating many little businesses that sell products. And so a product is products. And increasingly, one of the products is research itself. There are some projects that use the whole lab network to do research and development. So there's a project developing unmanned aerial vehicles that's using many labs all around the world to design parts of it. Where there, the product is close to what universities do. It's research and development, but the lab is the platform. So each of these is a kind of a product. A way you can think about this is the labs are a bit analogous to when libraries were first made available. And if you ask, what is the product of a library? It entertains kids, and school children use it in their studies, and people use it when they're starting a business. And it's a slice across all of those. So many people think that the product is products. It's businesses you make in it. And that is one of them, but it's only one of them. And in many ways, all these other ones are, if anything, more important overall. Now, to your second question of who runs it, it's a really interesting question. Not just fab labs, but many different things emerging today happen in networks without leaders. Like the Linux operating system is an example, or Wikipedia. Each of those, Linux has Linus Torvalds, Wikipedia has Jimmy Wales, Fab Labs in a sense has me, but we're not really in charge. We help shepherd. We have a central role, but it's a very distributed network. And so as the network has grown, MIT and I continue to have an important role in the technical roadmap. What are the frontier capabilities that go into the lab? What's emerged is a network of regional foundations. This is getting started in Russia, but in the US, in Europe, in India. What these foundations do is they provide logistical support, operational support. They help with things like supply chains and accounting and reporting and things like that. What's emerging are funds to invest in the businesses in the lab. And again, this educational platform linking the classes. So each of these is an organization, but each of these organizations is distributed. It's not a room, it's a group of people. And then the Fab Lab network is sort of a network of those networks. And so there's a lot of work that goes into aligning the network, in managing what's in labs and tending the inventory. But it's done by lateral alignment, not by top-down command and control. On the one hand, that makes it more chaotic. On the other hand, it makes it much more powerful and much more scalable because it's not limited by that central point. So it's really a distributed network. And if you're interested, I can tell you more about each of these.
Hi, I'm Sergey Frankov from Startup Accelerator Ideal Machine. Can you talk a little bit about commercial model? How a business can get involved in the startup business or existing business?
Sure. So commercial model. So there's a couple parts to answering that. And the obvious thing to do, which you'd think of, is you use the Fab Lab to invent a product, and then you make a business to sell it. You can do that, but it hasn't worked, that part hasn't worked all that well. And one of the reasons is existing businesses, if you try to get them to use the Fab Lab, they use it to do what they're doing just using the Fab Lab. So that existing businesses tend to do what they would have done anyway, and the Fab Lab has little impact on them. What's been a bit more successful is creating new businesses. And so there are a lot of examples of little businesses coming out of the lab. Like, the lab in the north of Norway, there was a chocolatier who had a lot of trouble with tooling, and so they used the Fab Lab to do custom tooling for chocolate and produce that as a nice business from the lab. So there are examples of new kind of workflows for businesses that represent new processes. Those have been more successful. However, they all struggle with scaling, because the issue is there's only so much you can produce in any one lab, and sending it off to China for mass production defeats the purpose. And so what we're just beginning to see is a new thing, which is more analogous to something like iTunes or Android Market, of beginning to have marketplaces where you design something in one lab, but it gets produced all around the world on demand, and the production all around the world has a return back to the developer. And so there, the limitation isn't the inventiveness of the designer or the demand of the market. The limitation is the lack of the business platforms for the distributed buying and selling. And so I'd say the biggest opportunity and the biggest challenge isn't in the invention, but it's in developing new business platforms that let you scale the business by leveraging the power of the network. Likewise, and coming back to that earlier question, every one of these bullets is a business model. So for example, there's a very successful Fab Lab in Detroit. And their funding comes from kids who go to jail. And the reason is a lot of money is spent on social services of kids who are either at risk or already in the jail system. And what they're doing is they're using the Fab Lab as a social service where it takes at-risk youth and engages them in society. And they're getting paid not for the products, but for the social impact. The lab I showed you in Barcelona, that one is funded out of education. They're providing faster, better, cheaper technical education, so they're funded out of the classes. The radio network I showed you in Afghanistan, that's running on a commercial basis, for example, in Kenya, where they're funding the lab out of the infrastructure that it creates. There's a lab in Manchester, a lab in Tulsa, that's developing funding for its development of, I mentioned the example of the unmanned aerial vehicles for use for things like precision agriculture. And so lurking behind your question again is making businesses tends to assume you invent a product and sell it. For that to really work needs invention in the business platforms. But a lot of the businesses emerging in the Fab Labs have to do with these other things. And this is, it might sound trivial, but it's a fairly profound point. When Sergey and Larry started Google, they had no idea they were an advertising company. You know, it took other people later to figure out that what you actually sell is the advertising, you don't sell the search. In the same sense, it may well be that after we're done a decade of doing this, that the designs are so fluid that these other things are what really are the economic drivers, not just selling selling individual products. So I think the whole notion of who pays whom for what is a profound question, a really interesting question. It's not an obvious question. What we're finding is the answers aren't familiar business models. And then the other thing we're finding is every one of these, to make it into a business, needs organizational capacity. To sell the impact on youth, you need to package the lab so that it can work with a social service agency. To sell the education, you need a platform that can recognize and accredit the education. Each of these, to create the business, you have to create capacity and organization that goes along with the business. So, I'll end by, in a sense, asking you the question, given this sort of hive of activity, figuring out who pays whom for what, the only thing I know is it doesn't look like the last round. The traditional Silicon Valley model, where you all go to one place, you get a pot of money, you invent something, and then somebody mass produces and ships it. That's the one thing this doesn't look like. Really figuring out those new models it is the project, is the question. There are many experiments, and nobody knows the answers.
Thank you.
Yep.
Antonio Sov, Sankt Petersburg Polytechnical University. Thank you very much. Very interesting lecture, and idea of distributed personal production is really great. But can you please comment on the following analogy? Software. Actually, everybody who has computer can produce software, but still there exist huge companies for software.
Mm-hmm.
Still, so how you can you comment on this?
Sure.
Thank you.
So, anybody with a PC on their desk or a phone in their pocket could create software, but Microsoft still exists. So the answer to that is, this is very precisely following the history of both software and music, but now for things. So software, IBM wrote it, Microsoft wrote it. Along came Linux. There was this brief spike of, yippee, it's free. Nobody's ever going to pay anybody for anything. Then that didn't work so well because there needs to be sustainable business models. But instead what's happened is an ecology of markets. So there's still the hive of open source, freely available software. There's freely available software where you charge as a service. There's apps where you pay $1 for a little program. And there's apps for one person that gets sold to 10 people, 100, 1,000. There's apps that go up to 1 million people. There's commercial software still being sold. And then there's the giant things like giant databases sold to big companies at huge fees. And so the ability to write software didn't eliminate big companies and big software, but it made viable a hierarchy of markets of 1, 10, 100, 1,000, 1 million. So in the same sense, music was owned by the labels. Napster came along, yippee, it's free, nobody pays anybody. There was the fights over rights management that failed. And now what's happened is there's still the labels and pop hits that sell 1 million, but now there's bands that sell to 1, 10, 100, 1,000. There's this whole ecology of garage bands, track sharing, micro labels, all of that. It's opened up tiers in music that didn't exist before. So in the same sense, the Fab Labs don't replace mass production, but mass production is by definition for the least interesting things. You mass produce the things for which everybody needs the same thing. You don't need a Fab Lab to make a nut and a bolt. That's so standard you could mass produce that. But you use the lab to make what's not standard. In printing analogy, there's high throughput web printers, and then you have an inkjet printer on your desk. And you use the inkjet printer when everything is different. You use the web printer when everything is the same. You create that whole ecology of markets. And so what it'll make viable production for 1, 10, 100, 1,000, production on scales that weren't viable before. It doesn't eliminate mass production, but it opens up all these new tiers. And it's pretty precisely just replaying the history of software and music, but now for things.
Hello, Sankt-Pетербурg, Open Urban Lab, St. Petersburg. I have a bit of technical question. How it works technically? Now, if you can clarify in more details how Fab Lab works at technical level.
Yep.
Do you have kind of a central computer where people program all these machines?
Yep, okay. So technically, what's in a lab? There's a base inventory for a standard Fab Lab, and it's about $100,000. Now, to understand that, you can make a little, in the machines that make machines, this one was designed to be done as cheaply as possible. This one is about $100. This one is fancier. This one is a few hundred. This one is a little more capable. It's 1,000. So you can make a machine for a few $100s. The inventory in the Fab Lab is not this machine. It's the machines you need to develop and make the machine. So the Fab Lab is the machines you need to develop machines. You can make a fabrication facility for a few $100s. The investment in the lab is what you need to be able to develop all of this from scratch. So, and then what's in the lab, on the one hand, the cost is coming down as we move towards making the machines in the lab. On the other hand, the cost is going up because people's ambition keeps growing. People increasingly want to do things like molecular biology or microscopy or more advanced things. So think of the lab as an investment that's comparable to your town library. So now what's in the lab today is, in the current inventory, we have a 4-foot by 8-foot by 1-foot large format milling machine. And we use that to make furniture, houses, boats, things like that. Very large format machining. We also use it to make large form molds for laying up composites. And that's about a $15,000 tool to make big stuff, bicycles, things like that. There's about a 45-watt, couple-foot CO2 laser. That cuts out part to make it can engrave, but the main use of that is cutting out parts to assemble 3D structures from 2D parts. The computer-controlled, and then it needs air handling for exhaust and suppressing flames to use it safely. The laser is by far the most used tool. There's a 3D printer to print objects, and most people think Fab Labs means 3D printing, but we use that about maybe 20% of the time. The laser is used much more than the 3D printer. It's more useful. You can make things much faster with it. But there's some things you need the 3D printer for. There's precision numerically controlled machining. We use that for soft tooling. Instead of 3D printing, I prefer to make molds for casting because you can work in cheaper, higher performance materials and do production runs. So we do soft tooling, but we print when you can't do molds. The precision machining is also used to make circuit boards by subtractive machining, so there's no chemical waste, so you just vacuum up dust. Then there's a whole suite of electronic parts for power electronics, embedded programming, RISC microcontrollers, sensors, things like that. Development tool chains for talking to embedded processors. Those of you who are familiar with Arduinos, the whole point of the lab is not Arduinos, it's a step upstream from that. Arduinos are just Atmel processors with a standard development environment. The point of the lab is you can make Arduinos, but you can make other things that involve processors beyond that. Then there's a suite of actuators, motors, mechanical parts to build things like motion control and robotic systems, materials for molding and casting, then a mix of open source software, and then we rewrote the CAM internals to run all the machines, because each of the machines has problems in what it can talk to. So we rewrote all the software that talks to the machines, so any design can come out on any of the machines. And increasingly, we're now beginning to take over rewriting the CAD tools. That's still coming. But the internals, the CAM that runs the machines, we had to rewrite because that was a big limitation. So all of that is what goes into the lab today. And then there's some supporting things, like tools for video conferencing to link to the other sites around the world for classes, some supporting capabilities like that. So all of that adds up to about $60,000 in equipment, about $20,000 in parts, and maybe then $20,000 or so in site prep. And again, to be clear, just to make stuff, with the tools in a fab lab, you could make a machine for a few $100s. And our goal is for all the machines in the fab lab to be made in the fab lab. But a lot of the cost goes into things like the electronics inventories or the specialized materials or the large format machines that are still a ways off from coming down. So in scales, the fab lab is what you make, lets you make machines that then make machines. And so that's the investment in the lab. Okay?
My name is Edgar. Hi. Do you have special library inside of Fab Lab? I mean, for example, database of ideas, access to some patent libraries outside of Fab Lab, etc. And are you giving a chance to use different patents for your kids?
Yeah, yes. Here's why. The answer is yes, with a couple notes. Remember, there is no central organization, so there is no the central site. But one of the things the labs rests on is distributed version control systems. For those of you familiar, Git or Mercurial. And so it consists of something like a database, but instead of being in one site, there are many, many local copies, and you can work on it locally, but then you share your work with others. So we have archives of instructional material. We have archives of projects, but generally they're all developed. So for example, all the students coming through these classes develop their own tutorials and they develop their own projects, and then they all go into these distributed version control systems. And so we have both those and we have some ones for work beyond them. So we have archives full of projects, instructional projects, practical projects, and training material. But it's developed in a distributed way. And the IT itself is distributed. It's based on not having a central server, but doing distributed version control. So the answer is more than you wanted. It's all over the place, but it's not centralized at a single point. It's distributed over the network.
Do you have
Good afternoon. My name is Yuri Shinin. I'm representative of the group called Mir Kupalov organization, doing with design and also individual projects of domes. My question is, on principle, these individual projects, and this is our task nowadays, we are developing the so-called container, a machine producing these domes on the site indicated by the client. For example, in the village, they would like to build up a house. We come with the container with this kind. This is a kind of the laboratory, and produce everything which is necessary on the site. Do you have any kind of examples of mobile laboratories? The project in Barcelona, which you described, is very close to me. Are there any other projects like that?
Mobile labs, yes. This trailer is a complete fab lab. Everything I described fits in this trailer. We picked that in the US. These are used to drive around racing cars to racetracks. And it's the largest trailer you can drive without a truck license. And so we designed a lab that fits completely in that trailer. So you can do that. And there's a few other sites developing mobile labs. The only problem with the mobile lab is whenever we move it somewhere, people don't want it to leave. So we have a terrible trouble moving the mobile lab because people want to keep it wherever it goes. And so for that reason, it's, if you think about $100 minimal machine, $1,000 machine, and then the investment on this larger scale, this is still a tiny investment on the scale of something like, again, infrastructure in a town or a library. And so we found generally it's a better idea to encourage people to just make lots of local labs instead of moving the lab. We thought this would be a good idea, but people don't like it to move, so we try to get them to set up their own lab. But yeah, sure, you can fit the lab in a trailer, and we have done that.
How does the Fab Lab affect the quality of innovation?
Yeah, how does Fab Lab affect innovation? Let me echo something I said a few minutes ago. There's a lot of attention to we want innovation. But what it tends to miss is something I mentioned. Innovative people are strange. They generally don't fit well in society. They tend to fight with their teachers. Often they give up and leave school. Exactly the innovative people everybody's looking for tend to be very unhappy in programs called innovation. So we've set up Fab Labs in war zones, but that's easy compared to our experience setting them up in traditional schools. Because in the school, somebody says, right, we're going to do innovation, and here's the lesson plan, and here's the test on innovation, and here's the schedule for innovation. We do have Fab Labs in schools, but they work best sort of at the edge, in informal settings. So they need to be available at nights, on weekends. You need to be able to use them to do things driven by curiosity. Now, all the time isn't the same. A typical lab, some time is for classes, some is for business, some is for art, some is for play. It's not, there's different types of time. But it needs to be accessible to somebody who has ideas, but they can't really explain it and can't really justify it. And so when you get that right, a lot of the knowledge in how to use the lab comes from users teaching users, from the user community. And you need to kind of prime that pump that allows user-driven education. Like, we really struggled with some labs in India where teachers don't like their students to know the students know more than them. And so the teachers would sort of fight with the students to try to tell them what to do, even though the students knew better. The art is to make it in a place where it's accessible to informal learning. And then what happens is they become magnets for inventive people. So much of the, I showed you some of these images of people like, Chapiso in South Africa or Hans Christian in Norway. The people like that then migrate to the lab because it's a place where they fit. And it's creating safe places for inventive people that don't fit in society. Now, one of the things to get right is in pairing the labs with things like the university sites we're talking about, there's a flip side, which is inventive people like Hans Christian also need mentoring. They have brilliant ideas, and they also have a lot of dumb ideas. And they need an environment that can tell them, no, that's actually a dumb idea. It's been done before, and here's why it'll fail. And so part of the art is keeping it open and flexible, but having mentoring that can help the development of them. So the social engineering is really important. Making it a place, I'm sure you know people like these, making it a place where people like that are comfortable is essential to the lab. And the answer is, this is really directly addressing what's so important, so many people say so much about in empowering innovation and knowledge economy. But it's doing it not by pouring $1 billion into a single hole in the ground, but by creating these environments that are accessible to people. And so, again, the challenge there is this works as long as you don't kill it, as long as you don't kind of strangle the process, as long as you make it open for people like that.
Vasiliev Alexander. I represent an initiative group for the promotion of 3D printing. First of all, thanks a lot for your lecture. And I did not expect to see you in person. The most interesting question for me is, are these educational materials accessible of your Boston Fab Lab? For example, in the internet, we would not like to repeat the steps already made by you.
So two comments. The first comment is, people who know me know that I don't like 3D printing. And the reason is, it's not that I don't like it, it's that I like machines that make things. So this one dispenses. This is a multi-axis. This one extrudes, this one cuts. This one is large format, this one slices. And with all of these, again, 3D printing, meaning extruding a plastic bead, maybe I use 20% of the time. Maybe 20% of the time, like I like to use computer-controlled cutting in copper to make flex multi-layer circuits. I like to dispense fluids for things like electronic materials. I like to mill circuit boards. Instead of just 3D printing, the whole point of projects like this is to take the machines and let them do many different things. They can cut, scoop, deposit, print, in this range of workflows. And if you're already building 3D printers, it's a very small step to move from there to all of these capabilities. And what I like is having that whole range of capabilities available. So that's one comment. To your comment is a really important question. Again, if we go back to things like these meetings of the labs and these organizations, we had a problem that every single lab was developing the same tutorial material. So they would all develop instructions to do the same thing. And they were developing many versions of the same project. So your question is a really good one to say, how do we build on that instead of doing it all over again? And I can show you more in detail, but in particular, this Fab Academy project is working really well to address what you're asking, because we have all the labs around the world, but we have some super labs that have very strong instructors and good technical bases. And those labs end up being host sites to manage the Fab Academy. And then together, the network of instructors is building a lot of the tutorials and class material. So I'll be happy to show you where it is. It's a very important question. It's a key question. And the answer to it, again, rests not simply on MIT, but on the network of gurus in the lab. So here, there's Frosty in Iceland, and Alex in Amsterdam, and Tomas in Barcelona, who are these wizards who have a sort of a more important role in helping manage content that helps the whole network. And I'd invite you to work with them. Yeah.
Hello, fellows, Lectorium Center. You told us about Lego infrastructure that help children to build big construction. Right. So, do you provide any kind of standards for different fab labs so the products are compatible with each other and have interoperability?
Yeah, that's a very interesting question. The projects are too diverse to narrowly come up with something like a instruction system or an API. There's just too many different things going on. So in a sense, the answer is yes, but the standardization comes from all of the labs have the same capabilities, and all of the people interact. There's a notion of a fab charter of rights and responsibilities. There's ways the community works. So in a sense, the standards are the infrastructure and the community values. And then within that, there are projects that link all the labs. Like the community wireless, RF was done at MIT, process in the Boston lab, RF field testing in the Norwegian lab, field trials in South Africa, deployment in Afghanistan, commercial use in Nairobi. That's a project that went all over the world and had many people working on it. But there's so many different projects. We haven't really tried to define technical standards. It's more infrastructure standards and human standards that there are a number of different examples like that of those projects. It's an interesting question. The ultimate answer to the question comes when we move towards these digital materials, where the standards are enforced in the materials. At this stage, there's just such a diversity of what people do. I love the question. I'm not sure how to go about it. How to come up with standards that meet, other than these infrastructure and these human ones, that meet the range of what people do in the network. It's a very interesting question.
Good afternoon. My name is Sычkov Vitaly. And I'm one of the organizers of the Hikers organization in St. Petersburg. My question is that, do you cooperate with such organizations, Fab Lab?
To be clear, in a sense, there is no you. I'm not Fab Labs. There is no Fab Lab company, or it's the network. So for example, this lab is a few hundred miles above the Arctic Circle in the Arctic Alps in the north of Norway. And Håkon is a Sami-descended herder. And this lab started because the sheep and reindeer would go in the mountains. And for herding, they started putting cell phones on sheep and reindeer in the Alps. But there wasn't phone service, so they started needing to make their own radios and antennas. And so we worked with them to create a lab there. And so this is one of the most beautiful places on Earth. And a lot of this work, the work of this lab, happens making technology going off hiking in the mountains. Many of the labs are in beautiful, remote places, closely integrated in nature, and that's their interest. There's a lab in the west of Kenya that runs completely off-grid, where it's solar powered and it's a completely autonomous lab without a conventional supply chain. So many labs are interested in that, and I'll be happy to introduce them. It's a reflection of how people use it. It's not a central question, but there's labs in many beautiful parts of the world. And one of the fun things also is all of the people in the labs are kind of the same. They're all similar in a nice way, and they really enjoy each other. So there's a lot of travel in the network. So Håkon built this Viking longhouse, and then he built Viking cabins around it, and he loves to have people come visit him. So if you want to go hiking in the Arctic Alps, he'd be happy to host you. There's a lot of travel in the network.